All right, critical number. A critical number of a function is a number c in the domain of that function where the derivative at that point either equals 0 or the derivative does not exist. So those are the things you're going to see in graphs where something different's going on. Either you have a local max, local min, there might be some kind of corner, there might be somewhere where it's discontinuous if you have derivative not existing, there might be a vertical part. So you got to figure out from the function what's going on. Let's take a look at an example here. They want us to figure out what are the critical numbers of this function here. Well, to find that, we need to know what the derivative looks like because derivative determines critical numbers. To find the derivative of this, we could do product rule. I think this one's probably easier if we do a little simplifying first. So I'm going to distribute here. We get 4x to the 3/5 minus, this is like x to the first. So if we're multiplying that, we want to add the exponents. 1 is also the same as 5 over 5. So if we add 3/5 and 5/5, we're going to get 8/5. So that's just another way to rewrite the function. Now let's find that derivative. So the derivative here, using our power rule, bring down the exponent. So if we multiply 4 times 3/5, that's going to be 12/5. New power of x should be 1 less. So 3/5 minus 1 or 3/5 minus 5/5 is negative 2/5. Do the same thing on this other one. Bring down the power. New one's 1 less. Okay, so now what we want to do to figure out where the critical numbers is see where this derivative equals 0. In order to do that first, so I want to put this together and see what this looks like as one thing here. This exponent is negative, so I'm going to drop that down to the bottom here. So here's what we got now. I want to try to combine those into one. So I'm going to get a common denominator here by multiplying this by x to the 2/5. So it's the same, but that means the top I also need 2 times by x to the 2/5. So what is that going to simplify to? Well, now we got a common denominator of x to the 2/5. On top here, I'm going to have 12 minus 8 times, if we do x to the 2/5 times x to the 3/5, we add those exponents. 2/5 plus 3/5 is actually x to the first power, so just x. So that's our derivative combined into one here. Where are critical numbers? So one place to find critical numbers is where our derivative equals 0. So let's do that first. That derivative down there, right here, is going to be equal to 0 wherever the numerator equals 0. So if I set that numerator equal to 0 and solve it, that'll tell me a critical number. I'm going to add the 8x over and divide by 8 now, so I get 12 over 8. Or simplified, I think 4 goes into both of those, we get 3/2. So one critical number here is 3/2 or 1.5. So that's a critical number of this function. The other place we find critical numbers is where the derivative does not exist. So let's see if we got any points there. To get that, we're going to focus on the denominator, because the denominator, if that equals 0, we can't have division by 0. That point does not exist. So something's going on there and we don't have a derivative. So I'm going to set the denominator equal to 0 to figure this one out. So we can divide by 5. 0 divided by 5 still 0. Now to solve that, we can take both sides to the reciprocal power of 5/2. That's going to make this side x to the first power, because all these cancel out here. On the other side, 0 to any power, still just 0. So 0 is a critical value here, meaning something different's happening at that point as well. Just to check and see so that you guys can see that going on here. Let's just graph this function to look at it so you can kind of verify that. So if you graph, I'm just going to enter it the way it was originally given to us, x to the 3/5 times 4 minus x, and graph this out here. You can see two things here. One, why did we not have a critical value here? It looks like you can see it gets vertical there, so that's why there was no derivative there. And then critical value at 1.5 looks like there is a maximum there.